Good day, class. Our topic for today is estimation of parameters. As you all know, we have taken it up. Parameters, ito yung mga information about the population, no? But since hindi natin kayang kunin in a short period of time yung mga information about the population, we can only estimate. Okay? So pag-aaralan natin, paano natin ma-estimate? But before that, let's have some definitions and review of our former formula. Alam natin naman yung z-value is equal to x bar minus mu of x bar over sigma of x bar. Kung ang variable natin is x bar, then it's going to be as simple as the one on the left. Okay? Kung meron tayong information about the averages, no? Pero kung ang information natin is more on the individual or let's say nag-sample tayo ng isang grupo lang, so we only have information about that group. So we're going to use the average of that group minus mu of x, which is basically the same as mu of x bar, and sigma of x divided by square root of n, where n is the number of sampled groups. Itong sample groups, let's say, nag-sample ka ng 20 sections at kinuha mo yung average height ng bawat section, then your n is going to be 20. Hindi yung total number of students, no? Or individuals naman. Pwede rin individuals. For example, ano yung number or average number of hours studying ng isang student sa isang linggo. So, bawat estudyante magbibigay na ng kanyang average. So, we're talking here of number of averages, okay? So, sometimes, in-estimate lang natin isang value which is the average. For example, the average height of students or average grade. So, kukuha lang tayo ng isang information which is the average of the whole class. But also, many times, nag-i-interval estimate tayo. Meaning to say, hulaan natin siguro from ang average grade nila will be from 85 to 90. Okay, with a certain degree of confidence. Ang tawag natin doon is the interval estimate, which is the range of values calculated from a sample statistic and the standardized statistics such as the z, and the selection of the standardized statistics is determined by the sampling distribution. Of course, for our purposes, we just assume normally distributed functions, no? Pagdating nyo ng college, when you go to your higher statistics classes, that's the time that you will study other distributions, no? The selection of critical values of the standardized statistics is determined by the desired level of confidence. Again, sino ba nag-determine ng level of confidence? It is the researcher. So if you're the one doing the research, you will decide anong level of confidence ang gagamitin mo. But then of course, the rule of thumb, as I've said before, kung tungkol sa mga gamot yan or pagkain, usually, tinataasan natin yung level of confidence natin. Okay? May linaw ba? So, it is I. Or the boss will decide, no? Yung kung nagtatrabaho na tayo. So, the estimator of the population mean mu is given by the following formula. For point estimate, sa normal distribution, we use summation of all x's or lahat ng values, add natin lahat, divided by n, the sample size, which is exactly the same sa t-distribution. And the interval estimate will be x bar plus or minus z multiplied by sigma over square root of n. Similarly, you have x bar plus or minus t multiplied by standard deviation of the sample over square root of n. Very similar except for the z value here on the normal and t values for the t distribution. And you will have sigma if it's given sa normal and sample standard deviation for t distribution for using the t, no? And we know that when sigma is unknown but distribution is known to be normal, we can still, or sample size is 30, we can still use the normal distribution or the z table. Meron tayong correction factors for the means, okay, and the proportion. You would notice and see them in most of the statistics book in college, pero in high school, we will just concentrate on the standard one. Ang wala po munang correction factors. The correction factor will be for means. So we just add and subtract square root of population size minus sample size over population size minus 1. Okay. And for proportion, we have a plus and minus 0.5 over square root of n. By the way, yung una pala is we multiply by our MOE, which is this one, by this factor. Okay, we multiply. Pero sa proportion, we add and subtract. Okay. The distribution of sample means for 95% confidence, meaning to say, yung confidence level natin is at 95%. Of course, the total is 100% confidence, which is sure na sure ka, which is very unlikely in any experiment. Okay? And if you're talking about the normal table, when mu is equal to 0, that means in-standardize na natin using the formula kanina. At negative 1.96 up to 1.96, yung area under this curve from the left side to the right side, from negative 1.96 to plus 1.96, you will get from your table 95% or 0.9500. So, ang matitira is 0.05, hatiin pa natin sa dalawa. So, that means yung area nitong sa left is 0.025 at yung area to sa right is 0.025 also. Okay, so that the confidence interval will be from x bar minus 1.96 multiplied by sigma over square root of n to x bar plus 1.96 multiplied by sigma over square root of n. And the probability of that having your mean within that range is 95% or 0.95. Okay? Yun ang ibig sabihin lang na ang confidence level mo ay kapalo ng 0.95 or 95%. If you add the correction factor, you will just multiply the left side and the right side by square root of n minus n over n minus 1. Okay? So, yun lang naman yung dinagdag with correction factor. So, in our example, given that x bar is 1.63 and sigma 1.25, with the sample size equal to 60, if you divide sigma over square root of n, you'll end up with 0.161374. And so our range or the confidence interval will be from yung ating mean of 1.63 minus the z-value of 1.96 multiplied by this 0.161374. And then on the right side, we add 1.96 multiplied by 0.161374. Or our confidence level at 95% will end up with from 1.314 to 1.946. Malinaw ba? So, our mean of 1.63 will be in the middle of this. And the range from 1.3 to 1.946, we will have 95% confidence. This means that 95% of all sample groups taken will have their means within the boundaries defined as between the range of 1.314 to 1.946. Anong ibig sabihin nun? Kung nag-sample ka ng 100 groups or samples, groups, you will notice that 95 times their averages will fall within this range from 1.314 to 1.946. That is why meron kang 95% chance na yung averages nila magfo-fall dun sa limit na yon. Okay? With the correction factor, mag-iiba lang ng resulta. Okay? From magiging 1.323 to 1.937. So, if you look at it, maliit na maliit lang naman ang difference. 1.314 hanggang 1.946 naging 1.323 to 1.937. Okay. So, these are the summary of Z values at different levels at 90, 1.645, at 95%, 1.96, 98, 2.327, and at 99%, 2.575. If you notice, lumalaki yung range, no? From left to right. This means from negative 1.645 to positive 1.645. Okay? Habang tumataas yung ating confidence level. Of course, if you have a graph, okay, lumalaki yung area so that our confidence level also increases. And locating that in our normal distribution table, okay, at 95% confidence, 5% lang yung error nating matitira. Inati mo sa dalawa, that becomes 0.025 on both sides. Pag hinanap mo rito, you'll end it up doon sa area ng 1.9 negative, tapos meron kang 6 sa taas. So, negative 1.96 and positive 1.96. Meaning to say, itong 0.025, the area below negative 1.96 is 0.025. And in the same manner, the area above positive 1.96 will also be 0.025. Okay? Characteristic yan ng normal table. If you look at the student's T distribution table, which is this formula na hindi natin pag-uusapan na dinevelop ni Gosset in 1908, isang statistician siya sa Guinness Brewing Company. Nung gumawa siya ng paper, dahil bawal sa kanila ang maglabas ng paper, gumamit siya ng pen name na student. Okay, hanggang sa napansin ng marami na mukhang may sense yung kanyang ginawang formula na ito at yung kanyang distribution na ine-estimate ang isang normal distribution kung sakali mang less than 30 or kakaunti lang ang sample size o kaya naman mga information about the population sigma is not known, in-estimate niya using the distribution na ginawa niya, dinevelop niya. And if you notice, from degrees of freedom from 1 to 30, lumalapit ng lumalapit pataas ng pataas, palapit sa blue ng standard normal. Okay? Yun ang napansin nila pagka dumadami ang sample size. That is why many statisticians, they drafted the rule of thumb that if it's 30 and above, pwede na mag-estimate ng Z-table or normal distribution. Okay, of course, our DF or degrees of freedom is equal to sample size minus 1 for single variable. So, yun ang characteristic. It's also shaped like a normal bell. Okay, bell shape. Medyo heavier lang sa tails. Hindi kumukha ng normal. Talagang smooth yung pagbabasa sa sides, no? And of course, mas medyo mataba ng konti yung kanyang tails, no? Compared sa normal. And this is how you look at it. Let's say a 0.05 at 24 degrees of freedom, meaning to say, let's say n is equal to 25 minus 1, you get 24. Your t value will be 1.721 or 1.711. Okay? So let's have an example using that. Yung binigay ko sa table sa inyo, I already put there the confidence interval. So kung 95% ang confidence interval, you look at the table at 0.950. So at 25 sample size, you have a degrees of freedom of 24. You will have 2.064 as your factor, the t factor. Okay? So applying that, you have x bar 1.63 minus 2.064 multiplied by 0.025 because your sample standard deviation is 1.25 or your n is 25, you get 0.25. So it will be from the range 1.114 to 2.146. That means the probability that you will find the sample means kung nag-sample ka ng 25 is 95%. Okay? Or 95% of the time, the sample means will fall within this range of 1.114 up to 2.146. Okay, so that is how you locate the region, the T value under the region of T distribution. Okay, so at 95% confidence interval, okay, we use 2.571 if n is equal to 6 or degrees of freedom n minus 1 equals 5. So yun, dire-diretso lang to. Okay, don't miss or don't lose your file or your students T table that I gave you. Magagamit nyo yan hanggang college. Okay? This implies that the area between negative 2.571 to positive 2.571 is also 95% at 5 degrees of freedom. Okay? Now, let's talk about percentile using the T table. Since at 95 confidence interval, the remaining areas on both sides are 2.5%. Okay? Then the percentile of the data less than or equal to 2.571 will be 97.5 percentile. Bakit? Kasi 0.95 dito, no? Hanggang dun lang sa isang area niya na negative 2.571. Kaya lang, to the left of 2.571, isasama natin yung 2.5%. So, 95% plus 2.5%, you'll end up with 97.5%. Okay, clear? So, we're not talking only of confidence interval when we look at the T table. We can also look at the area below the T value, or in short, the percentile. I'll give more example on the percentile wherein you can apply yung sinasabi kong ina-add mo yung leftmost area. Nagiging one-tail. Okay, so sa comparison, going back, yung pink na to, degrees of freedom equals 1, tapos naging 5, naging 25. And if you look at the normal, very close sa normal, yung 25. As a matter of fact, yung 30 would already assume almost the normal. Okay, so we have here the appropriate form of estimator of the population mean. Ulitin lang natin. X bar is equal to summation of x over n. So you have x bar plus n minus z multiplied by sigma over square root of n for interval. Or you use the t factor multiplied by s over square root of n for t distribution. Okay? So I think that's all. And the next one that we are going to talk about is for proportion estimation. Good day, class. I hope you enjoy. Bye-bye.